Okay, this is where we left off with last time, correct? Okay, so I would expect that you know this. Why? What do we mean by these dots, X's, or E's? What are they referring to? Well, it is electrons, but more specific with electrons. Because if it's a valence electron, what does that mean? So, how do you know how many valence electrons an element has?
By what column is it?
Okay, so how many columns do we refer to this as their valence electrons?
7.
Is it 7 or 8?
7.
8. 8 is correct. Okay, so if that is the case, what blocks do we not refer to as far as an octet? Because an octet means 8. That's why you call it an octagon. Okay? So is that what you skip? Skip the D block and also the F block. That's correct. Okay? So it's only S and P blocks that we associate with these valence electrons. Okay, so for some of you who are still writing, this content is also available on the Science Channel that we had covered last week.
Okay.
Because if we don't get rolling, we're not going to have enough time to wrap up this activity, which I think is important. Okay, and if you're watching this and you're not in here, that's just the breaks. This was scheduled to do this activity today, but we can't, if we're busy, we can't be everywhere. Okay? If that makes any sense. In other words, you can't be eating and here at the same time.
There also known to be on Wait, when are we going to take our quiz? Did I just miss what you were saying? Yuppers. I'm sorry.
All right. So if you knew nothing about, or excuse me, if you read this, give me an example of an alkali metal. Why is that right? It's in the first column. Hydrogen, even though it's a gas, it has characteristics similar to that of the alkali metals. And that characteristic is what? How can a gas have something in common with a metal?
Does it have like the outer shell?
Right. What's a little more specific about the outer shell? Yeah, they have the same valence number. Hydrogen just happens to have one electron only and also one in its outer energy level. Lithium also has one valence electron. All the way down to rubidium, cesium, and francium would all have that same characteristic in common, one valence electron. Okay?
Plus you.
So what would your presumption be that after reading this portion, then you see this, now we see the boron family, then the carbon family. What tendency or repeating pattern do we see here? We're going from left to right by increasing by what number? By the number 1. Okay? So group 2, 2 valence electrons. The boron family is in column 3, so we've got 3 valence electrons. Same with the carbon family, okay? And then you could say, and so on and so forth. The idea that every time you go over one column, you're adding 1 valence electron. And the tendency that happens is on the left side, those metallic atoms want to give their electrons away. That's why they form positive charges. Elements on the right side have the tendency to gain electrons, and that's why elements like this one, if it's in column 6, remember, if it has 8 valence electrons, that makes it stable. So if oxygen being in column 6, how many more electrons does it want?
2.
So is oxygen's charge. In other words, the exponent in the upper right-hand corner of oxygen's box. Okay? The reason it's -2 is because being in column 6, it wants 2 more electrons. Once it gains 2 more electrons, it's got 2 more of those than protons. Okay? So if you do the math like we illustrated last week, okay, what is the atomic number for oxygen?
8.
Okay? And we said it forms that charge, correct? Okay? So then if we did this, okay, 1s2, 2s2, 2p what? 2p4 to begin with, because that adds up to 8, correct?
Yeah.
Okay? Well, how many electrons are in this outer energy level right now? Okay? And just like it said right here, oxygen is in column 6, just like what we see here. So, since it's in column 6, how many more electrons does it want in its outer energy level to become stable? So if we do an E and an E like that, okay, how many total positive charges does oxygen have? Okay? Okay? And how many electrons, in other words, numbers and letters in the outer energy level? Okay? 2 and 4, okay, gives you 6, okay? And then 2 more gives you 8, correct? It's now stable, so because it has 8 there, but then we got to add those 2. So how many total do we have now? Okay? So then when you add them together, when you add these 2 numbers together, what do we get? -2. Just like what we're illustrating there. That's where that charge comes from. Okay? This will make more sense, we hope, when we do this activity. Okay, because you've been doing this in 2 dimensions, which means on pencil and paper. Here we will see it in 3 dimensions. Okay.
3D.
Close. Yeah. All right. We're still recording. All right. So, column 7. Okay. Give me an example of a halogen.
Chlorine.
Okay, so in the upper right-hand corner of chlorine, what's its most common charge?
-1.
Okay, so that must mean it wants to gain how many electrons? Just 1. Okay, and these noble gases, do they have a charge to them? No, they do not. Why do noble gases not have a charge to them? They're already stable. How many electrons are in their outer energy level?
8.
Okay, there's only one exception to that. There's one element that's stable that can't
108.
have 8 electrons in its outer energy level. It's just not possible. The element is not big enough.
0.
No.
The 118.
Nope, that would have 8.
Radon.
No.
Helium.
Helium. Okay, tells you that right here. Okay, helium has 2 valence electrons. Why can it not have 8? What's the atomic number for helium? 2. So if it's going to be stable, it would have how many electrons then to be neutral? 2. If it has 8 electrons and 2 protons, that'd be a charge of negative what? 6. Okay? So helium just can't do that. The element's not big enough. Yes?
If you gave oxygen 2 valence, what were they calling it?
Electrons.
Electrons, would it turn into helium?
No. You cannot change. The only thing that can change an element is if it is broken apart with an enormous amount of energy. Okay? Nothing that's done here on Earth except for plasma. Plasma is the only high energy substance that could do that. Yes, what?
Isn't that what makes bombs? Splitting in half.
Oxygen.
Yeah. Splitting atoms. Hydrogen was the first one, but you still do that with uranium. Okay? So that does it for this chapter. I will give you directions on this activity. And again, sorry for those of you who weren't in here. We can't be everywhere at once. And that's just unfortunately how it works out. Tomorrow, we will be having your vocabulary quiz. And again, if we are gone, that's just how it is. We can't help that. If you are missing work, I highly suggest that you get that turned in. All right? So we will get started on this activity shortly. We'll catch up to you next time. Vocabulary quiz tomorrow. We're going to review. And I don't know how the exams are going to fall into shape as of right now. Plan on having those at the end of this week. We'll catch up to you next time.